So in this video, I want to talk about in a little bit more detail on what is expected of a student during the results section. So here you have the first cog skill that we have in this section, which is identifying patterns and relationships. So if you just make a data table in a graph and briefly describe anything that you've seen on your results, that's just a tool. That is the lowest level of what we need to do. In order to score higher than that, you actually have to explain these patterns with some logical reasoning, including what does the trial say about your predictions, about your hypothesis. So in other words, not just have the data and talk about what happened and spot some patterns, but actually say, well, this trial was different from this trial, or these conditions were different from these conditions on average because of this. And because of that, I know that my prediction was wrong or not wrong, and so forth. If you do a simple bit of math, is also required. If you look at the bottom here, you have to some computation to see the similarities and differences between the data. And so that could be an average, that could be a ratio. We talked about that in the other video. But to score even higher, you actually have to analyze the patterns, explain with logic why is it that the results are telling you what they're telling you, and do a little bit more advanced math, right? So we include things like not just averages or just ratios, but do more math. And the difference between a 4 and a 5 is just if you do everything right. If your graphs are good, if your data analysis is good, then you score a 5. And so if you look at this in the exemplar, which I'm going to try to open on a different screen. And of course, the exemplar is not like anybody's particular lab. I made sure of that, but it's basically, this is if you had changed the pH. And if you look at the results, you have a nice table with all of the data listed, including the units. You have titles, you have labeled for every axis, you have the independent variables on the left, you have the dependent variable on the right, you have all the days. You also made some observations that you added to it. Then you included a graph that also has labels, units, title. Everything is pretty good to compare the groups. But more importantly, I pick up patterns. For example, I say that in the table, in the graph shows that there's a trend for growth. By the way, I made both a bar graph and a line graph. So here's the line graph showing the growth over the period of days. And so you can say, oh, I see a pattern that the red line is faster, and then the blue line barely changes. So the pH of 7 was the best growth. It happened the fastest. And the pH of 3, which was the acidic one, was the worst growth. So if you pick up those patterns, which can also be seen here by the average final growth, and you point them out, boom, you were at a 3. And you were at 3 because in order to do this graph, you had to calculate averages also. So you did some math. But to actually get a 4, you have to explain or interpret that data and explain what does that mean about your results. So you can see I'm saying this in the bottom here. These results indicate a clear relationship between pH and plant growth, with normal pH being the best as predicted. And if you explain what the data is saying about your results, if you compare them, that is how it looks like. Another piece of evidence here that shows that I don't put just one pattern. Look, another interesting pattern is as the alkaline condition, plants grew better than the acid conditions. So I'm comparing one condition to the other. Also, all the trials of the acid condition were lower than the trials of alkaline condition. So I'm giving more than one pattern, and I'm explaining what that patterns mean as far as my prediction. That's what a good result section looks like.